Hello, my name is Anthony Barreto, and this presentation introduces a launch business concept called CFLS, or Communicating Financially Launch Services. This concept explores a new operational model for the launch industry that combines three elements: a financial and contractual coordination network, a satellite infrastructure layer, and affordable small satellite launch services. The idea behind CFLS is that as the space economy grows, launch infrastructure and economic coordination will need to evolve together. This project explores how those systems could be integrated into a single operational framework. So the CFLS concept integrates three primary components. First, the financial and contractual coordination network. CF network is a cryptographic coordination system made up of interconnected nodes such as companies, organizations, government agencies, and independent operators. Each node operates through smart contracts that define conditions under which financial or operational actions can occur across the network. Second, CFLS deploys satellites that extend the network when space-based infrastructure is required. These satellites support communication, coordination, and operational visibility across distributed participants in the global space industry. Third, CFLS develops an affordable smart lift launch vehicle designed to deploy satellites for both the network and external customers. The overall goal is to create a scalable launch infrastructure using a standardized operational model similar to the Toyota-style approach used in manufacturing, emphasizing repeatability and cost reduction. Launch missions require coordination across many participants, including satellite manufacturers, launch providers, suppliers, and regulatory authorities. Many small satellites currently rely on rideshare launches to reach orbit. While rideshare programs provide relatively low-cost access to space, they also introduce important limitations. Rideshare payloads typically have limited control over launch schedules and orbital destinations because they must follow the mission requirements of the primary payload. At the same time, the small satellite market has grown rapidly over the past decade, expanding at roughly 23% annually. These conditions create increasing demand for dedicated launch services that provide greater schedule flexibility and mission control for satellite operators. CFLS targets the dedicated small satellite launch market. This segment includes missions requiring deployment to low Earth orbit or sun-synchronous orbit, custom orbital insertion, and flexible mission scheduling. Unlike rideshare launches, dedicated launch services allow satellite operators to control launch timing, mission configuration, and orbital destination. This flexibility is particularly important for constellation deployments, infrastructure satellites, and time-sensitive missions. As the number of small satellites continues to grow, dedicated launch capability becomes increasingly important for operators that require precise mission planning and operational independence. The broader space launch services market represents a large and expanding opportunity. Globally, the launch services market is valued at approximately $15 to $18 billion annually and is projected to exceed $40 billion by the end of the decade as satellite demand increases. Within this market, small satellite launch services represent one of the fastest growing segments. CFLS targets a portion of this market by providing affordable dedicated launch services while also deploying satellites that support the CF coordination network. Space transportation serves as an enabling capability for commercial satellites, national security missions, and scientific exploration. Meeting demand for launch services is likely to continue expanding as the space economy grows. CFLS targets a market opening created by three converging trends. First, demand for satellite deployment is increasing rapidly as commercial, scientific, and national security applications expand. Second, launch costs remain a significant barrier for many organizations that want to deploy infrastructure in orbit. And third, broader economic disruption from automation and artificial intelligence is reshaping how organizations coordinate projects and allocate resources. CFLS addresses these conditions by combining affordable launch services with a coordination network that allows organizations to negotiate contracts, finance projects, and coordinate operations more efficiently. Research suggests that lower launch costs can significantly expand commercial space activity. At the same time, emerging technologies are pushing industries to adopt new coordination and economic models. CFLS positions itself at the intersection of those changes. The current small satellite launch market includes several major providers. SpaceX offers rideshare launch opportunities that allow small satellites to reach orbit at relatively low cost. However, rideshare payloads must operate within the schedule and orbital parameters of the primary mission. Rocket Lab's Electron rocket provides dedicated small satellite launches with a payload capacity of roughly 300 kilograms to low Earth orbit. Firefly Aerospace's Alpha vehicle offers larger dedicated launches with a payload capacity of around 1,000 kilograms. CFLS targets the gap between these options by providing affordable dedicated launches focused specifically on small satellite operators while also integrating a coordination network that supports infrastructure and deployment planning. The CFLS launch system is designed as a standardized small lift launch vehicle capable of delivering approximately 400 kilograms to low Earth orbit. The vehicle uses a two-stage architecture powered by LOX and RP-1 propulsion. This propellant combination has a long history in launch vehicle development and is known for reliability and relatively straightforward manufacturing. The design philosophy emphasizes standardization and repeatable production in order to reduce costs. Operationally, CFLS would rely on a horizontal supply chain model, where specialized aerospace suppliers produce components while the company focuses on vehicle integration and launch operations. This approach allows the organization to concentrate resources on launch capability while maintaining flexibility in manufacturing and supplier relationships. A key feature of CFLS is the integration between launch services and the coordination network. The CF network connects companies, suppliers, and satellite operators through a cryptographic coordination layer. Smart contracts can automate agreements, payments, and logistics coordination across organizations. As additional participants join the network, the system becomes more valuable because it allows complex projects to be coordinated across multiple independent entities. In the early stages, CFLS satellites would likely be deployed using rideshare launches to minimize development costs. As the network expands and demand increases, CFLS would transition toward its own dedicated launch services to deploy both customer satellites and network infrastructure. This phased approach allows the company to grow its operational capabilities while managing developmental risk. Developing a launch vehicle requires significant investment, but small satellite launch systems typically require less capital than larger heavy-lift vehicles. Historical examples suggest that development costs for small launch vehicles can range from roughly $100 million to several $100 million, depending on complexity and production scale. The CFLS program estimates a development cost between $200 and $300 million based on comparable programs in the industry. Operationally, the company aims to reduce costs through standardized vehicle architecture, distributed supplier networks, and phased development that begins with rideshare missions before transitioning to full launch operations. The strategy is intended to reduce early financial risk while positioning the company to compete in the growing small satellite launch market. The CFLS value proposition focuses on two main advantages. First, affordable access to orbit. CFLS aims to provide dedicated small satellite launches at a price point lower than many existing providers. Dedicated launches allow satellite operators to control mission timing, orbital insertion, and deployment strategy, rather than adapting to the schedule of a rideshare mission. Second, the coordination network creates additional value beyond launch services. Blockchain-based systems can enable trusted coordination across organizations, allowing participants to automate agreements, manage shared infrastructure, and coordinate complex supply chains. Together, these capabilities position CFLS not only as a launch provider, but also as a platform supporting long-term infrastructure and collaboration in the growing space economy. The CFLS business model includes several potential revenue streams. Organizations can participate in the coordination network and use it to negotiate contracts, coordinate projects, and manage financial agreements through smart contracts. CFLS also provides the legal and technical infrastructure necessary to operate the network, along with ongoing maintenance and operational services. Finally, launch services generate revenue through satellite deployment for both commercial customers and infrastructure projects operating within the network. As more organizations participate in the system, the network becomes more valuable, creating a growth model where both launch and demand and coordination activity expand over time. The development plan for CFLS is structured in phases to manage technical and financial risk. In the first phase, the focus is on developing the terrestrial coordination network and onboarding participating organizations. In the second phase, the network expands and early satellites are deployed using existing rideshare launch opportunities. In the third phase, CFLS begins development of its standardized small launch vehicle, including design, manufacturing, and testing. Finally, the fourth phase introduces operational launch services, allowing CFLS to deploy both customer payloads and network infrastructure through its own launch system. This phased approach allows the company to grow capability gradually while reducing early developmental risk. The risk analysis evaluates several key uncertainties that could affect the success of CFLS. One potential risk is demand uncertainty. If low-cost rideshare programs continue to expand, they may reduce demand for dedicated small satellite launches. Another risk involves capital access. Launch vehicle development requires substantial investment, and securing funding can be challenging for new aerospace ventures. Technical risk is also present, particularly during early launch operations. Failure during initial flights could lead to regulatory investigation and loss of customer confidence. Operational risks include licensing delays and range congestion, which can affect launch schedules. Finally, there's adoption risks for the coordination network itself. Organizations may hesitate to adopt a new coordination platform unless it demonstrates clear operational and economic advantages. The 5x5 matrix illustrates how these risks vary in probability and financial consequence over a projected 24-month period. The space industry is entering a period of rapid expansion. Satellite deployments, commercial infrastructure, and new mission types are growing quickly, and demand for launch services will continue to increase. At the same time, the broader global economy is experiencing significant disruption from automation, artificial intelligence, and shifting geopolitical conditions. These changes are creating uncertainty in both public and private investment environments. CFLS is designed to respond to both of these trends by integrating a coordination network with launch infrastructure. CFLS aims to provide not only affordable access to orbit, but also a platform that enables organizations to negotiate contracts, coordinate projects, and manage complex economic relationships across industries. While the launch vehicle provides the physical capability to deploy space infrastructure, the coordination network creates a system through which participants can organize economic activity and collaborate even in uncertain environments. Over time, these networks can expand beyond the space industry itself, connecting organizations across many sectors and enabling new forms of cooperative market activity. Investing in CFLS therefore means investing not only in a launch service, but infrastructure designed to support the next generation of economic coordination in an increasingly complex world.